Good evening, everyone. Welcome you all to the day 4 of Margadarshi, keeping pace with the future of management. So today we are going to discuss about the topic data analytics stories so far and what lies ahead. So today we have with us Dr. Radhakrishnan Balakrishnan. He has earned his executive fellowship Ph.D. from Indian Institute of Management, Raipur, and completed his MBA from San John's State University, California. Dr. Radha has 25 years of industry experience spanning across India and USA. He had played senior management roles with HCL Technologies and Ernst& Young, handle high performance teams and delivered solutions on data management, data science, and data analytics. So, Dr. Radha's passion towards academics had driven him to quit his IT job and pursue his PhD degree in the area of strategic management. At Amrita School of Business, Coimbatore, Radha is part of information technology and analytics team focusing on the subject related to data science and data analytics. Over to you, sir. Welcome to Margadarshi Day 4.
Thank you, Rohan. Thanks for the introduction and thanks for facilitating this meet. Good evening, everyone. The topic for today is data analytics, story so far and what lies ahead. And this is the content we'll be covering in today's session. We would start talking about introduction to analytics, wherein I will talk about the importance of data and how data could be processed to convert that into meaningful information and meaningful inferences, on which then after which I would be discussing the types of analytic solutions. There are 4 types of analytics. Then I would be looking into a specific industry and then explain as to what kind of analytic solutions are being offered by the competing firms in the industry. Then I would look into 3 popular use cases using data analytics as a means to create a mark or to differentiate the firms from others. And then I would touch upon how analytics can go wrong in certain scenarios, and I would end up with a concluding remark. So to begin with, I would start discussing about the importance of data. I am borrowing some quotes from eminent personalities. In the interest of time, I'm not going to talk about these personalities. I would just cover what is mentioned by them. This is one popular quote. It says, if you have data, let us look at data. But what you have is opinion, then better we'll go with mine. So it emphasizes the fact that the decisions have to be backed by data. If you make decisions based on opinions, you probably will end up making very weak decisions. There is another quote which says, we are entering into a world where data would be considered more important than your other assets like software. To me, this quote is a bit old, and to me, we have already arrived into that era wherein the firms are considering data as the key asset for their organization. Pretty much all the organizations are building solutions and services centered around data. So we are already there, where data is the key asset for us. And that is actually, the concept is strengthened by this third quote, which says, there is a saying that if you get something for free, then you are the product. So for example, if you are getting free services from say social media, wherein you are getting content and also free videos and all that, in exchange, you are giving your data as the in exchange. So, which means data is all the more critical for organizations. many new generation digital firms collect data about their customer profile, customer buying patterns, behavioral pattern and all that, and they build value offerings based on that. So we have been talking about data so far. So I would like to discuss about data. How could you define data? Data is defined as a collection of facts. And what do we mean by facts? I probably would want to quote from some real life example. If you look at point of sale, the transactions made by people in a retail store, each and every transaction could be considered as one data point. A person ABC buying 3-4 different items would all comprise of one single data point. Likewise, a student appearing for a set of examinations and his individual marks in a bunch of subjects, that could probably comprise of one data point. So now from data, how do we get into meaningful inferences? So for that, we have to aggregate data, we have to organize, classify and process data to arrive at meaningful inferences. Only when we have information which is actually aggregated from data, then we could act on it. So for the information to be very effective, it has to qualify 3 criteria. One, information should be timely. If you look at this picture, funny picture, this says actually, this talks about the computing that happened maybe 25 years back. During those times, even for mundane, ordinary reporting, end of the day reporting and other things, people from different functional teams in the organization have to collaborate together to arrive at some report. And those information and those report were not created in time for decision making. So if the information is not available in a timely basis, it is of no use. The second one, information has to be accurate. In the data analytics world, we have a popular phrase that goes like this: garbage in, garbage out. So if you work with substandard data or data which doesn't have, is not clean or doesn't have good quality, the inferences you're going to make out of the data would be really bad. So the accuracy part would get affected. The third part about information is that information has to be complete. What it means is, when we build meaningful inferences, they have to be built based on the complete set of data. We shouldn't bank on partial set of data to arrive at inferences, and those inferences will be of no use. So when we process them, we have to make sure that we get complete set of data to arrive at complete information. If I have to relate back to the same example that we discussed, we talked about a person ABC making few transactions in the retail store. If you look at that particular transaction or the data point, that data point alone is not going to convey any message. It is not going to convey any inferences. But however, if you combine bunch of transactions, then you could probably figure out which product is being sold the most, which product is being sold the least, and things like that, right? In some cases, we could figure out whether the customers have affinity towards one particular brand of a product. So those things are possible when we do the processing of data to make it, to convert that into an information, meaningful inference. And if you take the students database example, if I just mention the fact that ABC has scored 70 marks in mathematics, that probably doesn't amount to anything. It doesn't convey anything. However, if I bring in one more statistic that says the average marks of the class for the subject mathematics is say 60, then we could make an inference saying that ABC is above average, right? So the idea is to aggregate all the data together, process them together to arrive at meaningful inferences. Now that we have defined data and we have defined information, now I am moving on to the definition of data analytics. Data analytics, people actually either use the term data analytics or they just say analytics. Both are pointing to the same thing. What it means is, the definition is collecting, inspecting, analyzing, discovering and arriving at useful information with which people could make decision. If I have to simplify this, it is all about, data analytics is all about collecting and processing data to arrive at meaningful inferences with which managerial decision making can happen. Okay. Data analytics has become the lifeline for all the businesses nowadays. Starting from the tactical decisions such as what went wrong in my operations floor? Why did my efficiency go down today? That probably could be some tactical decisions that people have to make based on for that question. Or it could be some strategic questions, which is more like which market I would want to compete in. How would I manage my product launch? So data analytics is going to be the key in answering questions to any of these tactical or strategic questions. And if you look at the way we process, the just the analysis alone is not going to be very helpful. We should be able to interpret from the analysis. Otherwise, we won't be able to arrive at some meaningful inferences. That is why the analytics solutions, data analytics solutions, is not a decision-making system. They are more of a decision support system. They enable managers to make decisions. They are decision enablers. So now that we have talked about what is data analytics, let us move on to the type of data analytics solutions. What kind of solutions we have for data analytics? We have 4 types of analytics: descriptive, diagnostic, predictive, and prescriptive. Descriptive analytics, it is probably the most simplified form of analytics. It is more of a superfluous thing where we don't have to dig deeper into the data. It helps to answer questions related to what has happened. What has happened? And sometimes with descriptive analytics, you could look into historical data to look at some trends and patterns. So if I have to give examples, for the retail world, if a firm wants to look into how many people have come onto my site and what is the footfall onto my site and how many people have bought, how many people have clicked my promotions. So those kind of analysis could come under descriptive analytics. And if you look at the industry examples, it could be like, if I have to work on some utilization reporting, productivity reporting on a daily basis or a weekly basis or a monthly basis, those reporting would come under descriptive analytics. So here we are just trying to answer the question as to what has happened. Moving on to diagnostic analytics. As the name implies, we are trying to figure out why some things have happened. Why something has happened. In other words, we could try to figure out the root cause for an issue. So here what we do is, we would actually look into coexisting phenomena, coexisting trends, to uncover any similarities, any correlations between 2 variables. If I have to quote examples, analyzing the reasons for an equipment or a machinery failure in an industry setup. The root cause could probably lead to your answer, which says that maybe a maintenance procedure was not completed successfully, which resulted in the machine failure. And if you look at another example, it could be a sales volume. How come sales volume has come down for a given product this week compared to last week? Maybe the promotional campaign that got launched was not effective, whereas the campaign was a lot more effective in the previous week, right? So if you look at both descriptive and diagnostic analytics, there are a lot of similarities. First one, they primarily use internal data from internal systems. For a firm, the firm has a lot of transaction processing systems which are implemented internally across all functions. So diagnostic analytics and descriptive analytics use the data from the internal systems, arrive at factual decisions. So the usage of descriptive and diagnostic belongs to era 1.0 of analytics, or we could call it analytics 1.0. So in analytics 1.0, we have made a shift from intuition-based decision making to facts-based decision making. So prior to analytics 1.0, it was more like opinion-based decision making or intuition-based decision making. In analytics 1.0 is where we started doing facts-based decision making. So, and if you look at the other similarities, the data volume for descriptive or diagnostic analytics is very small, because most of the data that you use is internal in nature, coming from the transaction processing system. It cannot be so huge. And also the pace at which the data was coming into these systems was relatively low. So then, the shift has happened from these solutions to another type of analytic solution, which is predictive analytics. Predictive analytics is useful to answer questions like what would happen in the future, what might happen in the future. So it consists of using statistical methods and techniques to predict future behaviors based on the things that have happened in the past. So we analyze historical data to produce easily and
Yes, Kiran, I can hear you.
sorry. Yeah. Okay. Sorry about that. Is it okay? Okay. Sorry. Okay. So sometimes when we work on predictive analytics, we would end up working with unstructured data. So those data would have to be converted into some quantifiable form in the form of some scores and things like that to for us to work on, for us to employ some statistical techniques. Right. If I have to give examples for predictive analytics, that involves things like recommendations offered by your Amazon and Netflix solutions, and predicting a fraudulent transaction happening for a credit card company. For a credit card company, there could be numerous transactions happening simultaneously. Maybe based on certain patterns and behaviors of a consumer, we could determine as to whether a particular transaction is fraudulent or not. Moving on to prescriptive analytics. So prescriptive analytics is ideal to answer questions like, what do you have to do now, given all your constraints? What do you have to do now, given all your constraints? So this is mainly for arriving at an optimal action. This is analogous to a doctor giving you a prescription. When you go to a doctor for a health problem, the doctor have multiple options to choose from to treat the patient. But however, he would want to hear from the patient on his health history, his family background, any existing conditions and whatnot, to understand what the constraints are, and then the doctor would prescribe a remedial action to treat the disease. Prescriptive analytics also works in the same way, where when we have multiple options suggested by predictive analytics kind of solutions, and we probably would have different constraints that we need to work with. Then in the given scenario with all the constraints, what would be the optimal solution that I should go with? That would be the prescriptive analytics part. So the ideal examples would be to arrive at an optimal marketing mix when you go for a target market, and then also optimal pricing strategy for pricing products. And if you look at predictive and prescriptive, that is when we moved from analytics 1.0 to analytics 2.0 era, 2.0 and 3.0. In 2.0, we have actually moved from facts-based decision making to include data from both internal systems and external systems. Initially, in analytics 1.0, we were handling only data from internal systems. In analytics 2.0, now firms have started accumulating data in the social media and other channels. So organizations accumulated all the data, aggregated them to process them collectively and arrived at meaningful inferences. And when they started incorporating this data from social media and all that, that is what is called as big data. I'll talk about big data in a bit. But with the arrival of big data, the computing environment and everything also got changed. I will briefly touch upon that, and that would be the that would be the analytics 2.0. From analytics to 2.0, now we are into analytics 3.0, which is more to do with data enriched offerings, where the data is getting embedded into everything. Data has become pervasive. It is embedded everywhere, into your product, into your service, everything. So that is the analytics 3.0. So predictive and prescriptive analytics have taken us from analytics 1.0 to 2.0 and 3.0 now. So far, we have talked about few examples more on a piecemeal basis, where I have not specifically given examples from one particular industry or anything. Now I want to address it from one particular industry. I'm choosing the gaming industry. Gaming industry is so huge. The worldwide revenue for the year 2020 for the gaming industry, which covers games on laptops and other devices, mobile devices, is $150 billion. So pretty much all the gaming companies use all types of analytic solution. And to begin with, we'll go with descriptive solutions. Descriptive solution, we are trying to answer questions related to what has happened. So with that, we are trying to answer questions like how many people are using one particular game? What would be the average revenue that I am making for each user of the game? Who are the new users and how often they are playing? And when players are using the game, are they making any in-app purchases or microtransactions? By the way, microtransactions is a very popular term used in the gaming industry. Microtransactions are made by people who are playing the game to make virtual purchases, purchase of virtual items with virtual currency. But the virtual currency, people buy the virtual currency with actual currency. So, for example, when people play games, if they have to get some booster options, maybe the superhero who is into the game wants to have additional power, then the player could virtually buy some power booster, which costs something. These are called microtransactions. Okay. In terms of diagnostic solution, we could think of solutions like, why do people leave in the middle of the game? We could actually do a root cause analysis to figure out what kind of improvement we could make in the game. Why did the active user base go down for a given product? And why is the game not popular among certain demography of people? If I have to quote examples for the predictive analytics part, we could quote something like, what kind of games we need to develop based on the user behavior. Maybe there are certain activities are liked by the users, certain set of activities in the game are liked by the users. So do we have to incorporate more of them in the future games? What kind of visual experience and graphics we need to come up with to increase the stickiness of users? What kind of gaming solutions can be built that can incentivize players to spend money on microtransaction? So what kind of features that we could implement that will improve the chances of more microtransactions? By the way, the leading gaming players, I'm not able to recollect the name of the firm. That firm has made $750 million in microtransactions through revenue from microtransactions in the year 2020. So the potential for microtransactions is way too huge. Prescriptive solution for a given player segment, what would be the most ideal game that one could launch, and what would be the right set of features that is going to maximize the potential of moving a customer from a free customer to a paying customer. Now that we have been discussing about the types of analytic solution, the question is, why is that we are using these analytic solutions? Why are they become so popular now? They are very popular now because of the arrival of big data, which has happened maybe 15 years back. Big data is data that qualifies one or more of the 3 V's. First one is volume, which talks about the number of transactions, number of data points that the system could generate. So if you look at social media, the data that comes into social media is huge. The data points are so huge. If you look at the credit card transactions, volume is very high. And velocity. Velocity is the pace at which the data is coming into the system. You could talk about social media posts, Twitter feeds, all those things have high velocity, very high velocity. And the third one is variety. In the traditional systems, we were using only structured data, dealing with numbers mainly. Now, the data that we are dealing with are, we have text data, we have video files, audio files, we have different types of data. So storing and processing that kind of data and all is very difficult. So with the arrival of big data, we have moved from analytics 1.0 to analytics 2.0, wherein even the computing paradigm, storage paradigm, everything got changed. But the major outcome of the big data processing is the 4th V, which is nothing but the value. The value that this data gives for the organization. Organizations could process this big data to arrive at data enriched products and services to stakeholders in the organization. Now, for big data processing, predominantly firms are using a lot of statistical techniques and machine learning and all that. So statistical techniques and machine learning are primarily part of artificial intelligence. So I want to touch upon what AI and machine learning has to do with analytics. If you look at the definition of artificial intelligence, as per the textbook definition, the AI systems, the idea of building an AI system is to arrive at a solution which mimics the user behavior, which is as smart as a human being. But in reality, we are not there yet. We are still getting to the stage where the systems are as smart as human beings. But where we are at now is that we have built systems that take inputs, process them, and produce output. And these systems can perform tasks which are so complex that are very difficult or practically impossible for human beings to complete. It is, for example, finding a fraudulent transaction in the big data kind of transaction scenario. It is not humanly possible for a human interaction thing to come up with fraudulent transaction, to identify the fraudulent transaction. But with the AI algorithm and a program, we should be able to do that in no time. Okay. So the definition for AI, I have put it there. This is actually suggested by the founding father of AI and cognitive science, which is Alan Turing. As per Alan Turing, AI computer program is one that a human can have conversation with and not be able to tell it was a computer. In case you are wondering why I am putting Benedict Cumberbatch's picture here, two reasons. One, if I put Alan Turing's picture, none of us would be able to identify, including the author of the presentation, which is me. And two, if then in that case, you must be asking why I am putting this guy's picture. There is a biography, Alan Turing's biography. There's a movie called Imitation Game, and Benedict Cumberbatch is the actor, which is streaming on OTT. In case someone is interested. Now, what are the factors that have made these AI tools very popular? With the onset of big data, we wanted to actually process all the big data. Firms wanted to process all the data. The computing paradigm has got changed. Initially, for handling traditional data, which was more to do with processing structured data, people were using vertical scalability servers, with which we could scale up vertically, which means we could increase the processing power of the same box. But with the arrival of big data, the scalability factor also got changed. We could scale up horizontally. So if we have to increase the computing power, I could add another server. I could add commodity cheap servers to take the burden from the main servers. Computing power has gone up. The pricing for the computing has come down. Storage, with storage like Hadoop clusters, everything, we got a lot of options for cheap storage. So with the proliferation of great computing resources and great storage services, suddenly there is an upsurge in the usage of firms, in the usage of data by firms. So initially, firms did not even bother about creating any value out of this data. They were buying all this computing power, and they were scaling up on computing power and storage, and stored whatever data that came their way. And slowly they started building products and services based on this data. And guess what? The AI techniques which have been around for too long, people started finding a need for those techniques. Right? This is how things have evolved when we moved from analytics 2.0 to analytics 3.0, wherein now we are dealing with data enriched offerings or embedded data in everything that we do. Now, I'm specifically going to talk about three popular use cases or three popular scenarios where analytics was very popular, and the organizations that use those techniques could make a difference. The first case study is Analytics in Action, Story of Beer and Diapers. There are various versions of this story available. In some versions, this story is attributed, this innovation is attributed to NTT data systems. In many stories, this innovation is attributed to Walmart. I'm not sure as to who did this, but I am attributing to Walmart because most of the stories are pointing to Walmart. But let's come to the story. It is all about Walmart when they were actually analyzing transaction happening in a single retail outlet. They found some interesting observations that on Fridays, the sale of diapers and beer were very highly positively correlated, which means there was a huge volume of beer sales happening, and at the same time, people were loading up on a lot of nappies for their kids. There could be, there are at least 2-3 versions of this story as to how it could have happened. It is more like the mother staying at home, she probably would have thought that things will get a lot more busier in the weekend. So she wanted her partner to pick up diapers before he or she gets home. Now, in that case, this person calls the partner and says, you bring the diapers. So when the male partner comes and picks up the diapers, then he feels that probably he could have a pack of beer since it's a weekend. So that is one. Number two, another story could be people, when men were sent to the retail store to get diapers, they didn't have time to go to the bar. So which means, at least they could use their time at the store to buy beer on the way back. Right. In any which case, when Walmart realized this correlation, what they did is they changed the physical layout in the store. They have put diapers and beers right next to each other in many of the outlets. And that has increased the sale even further. So then they could strongly postulate saying that the beer and diaper sales on Friday evenings are positively correlated, and they could actually make a lot of money on that inference. Okay, so they have used a concept called association rules. It's a data mining concept that they have used, with which you could predict as to which item can be cross sold. So that is a very popular feature used by a lot of folks now, especially for cross-selling. Cross-selling, for example, if you go to a car dealer, when you are almost done with the purchase of the car, then the car dealer will probably try to sell all the other fringe accessories. He might actually sell you the carpet, maybe he will sell you some audio system. Those are all cross-selling. Moving on to the second case study, analytics in action. It is about a sports organization, Oakland Athletics is a team. This thing happened sometime between 2000 and 2002. Prior to this time frame, Oakland A has lost a lot of seasons, a lot of games, a lot of seasons. And so which means, their brand value had come down. They had shrunk their budget to spend on players. So for the year 2001 or 2002, they had allocated only $40 million to buy their players for the team. Billy Bean was appointed as a manager for Oakland Athletics team. So what he did is, he was given the responsibility to choose the team. Okay, so if you look at the investment products, if you look at the prospectus of all these investment products, you will see some comments at the bottom of the prospectus. It says the past performance is not an indicator of the future success or something like that. And that is a lot more apt for the players also. So you just cannot rely on a player who was doing so very well in the past and assume that he's going to do very well and buy him. So he had to work with limited set of options, and also he had very little money. Three popular players those guys had, he let them go. And what he did is he used only two criteria. He was looking at how players behaved in tense scenarios. In critical games, tense scenarios, how well a player can hit and whether he can create or make runs. It doesn't have to be home run, which is like full swing. He could go around the circle and make full runs also. Okay. So he used those two statistics to do the analysis and picked players based on that. With that, they had a decent run of success, registering a 20-game winning streak to clinch the American League West title. For 3 or 4 years in a row, they were very successful. Okay. By the way, this Moneyball is actually written by a popular author, which was made into a motion picture also, in case someone is interested. Okay, the third use case, which is very popular and most of us could relate to, which is the recommendations provided by Netflix. Netflix began using analytics as early as 2000 to recommend videos for users. The personalized recommendation programs produce 1 billion in revenue, mainly by retaining the customers, customer retention. Customer churn in this kind of OTT platforms is really high. So the recommendations is one way to increase the stickiness for the platform. Majority of Netflix users consider recommendation with 80% of the views coming from recommendation. How do these recommendations happen? Two simple phenomenon. First one, there is a recommendation thing based on content filtering, which means when I register with, say, Netflix, at the time of registration, I would opt for certain type of content. Netflix has come up with around 20-30 genres for movies. So I could maybe choose action, adventure, thriller, murder mystery, those 4 or 5 choices. Then Netflix can push those movies. Whenever they create content in their site, they would define the genres. They would define all the categories corresponding to the movie. So if there is a match between my preferences and the movie's genre, the movie can get pushed to me. That is one type. But generally what happens is when the user registers, he doesn't give all the information. He actually does it in a jiffy. So not all his preferences are getting saved at that time. Then what happens is once you register, the user keeps watching content. The type of content that he watches often gets registered. Netflix tracks all that content that a user watches. And based on that, recommendations get pushed. That is it. So if you combine these two, it is called content-based filtering. And that is not the power of recommendation. That is probably the tip of the iceberg that Netflix is into. The key recommendation happens through collaboration, collaborative filtering, which works on the premise that if my likes and dislikes are similar to some other person's likes and dislikes, if two persons are having similar likes and dislikes, maybe a movie liked by that person can be recommended to me. Right? So they are using a lot of algorithms to find the nearest neighbor. The concept is called nearest neighbor. There are a lot of different algorithms can be used to find the nearest neighbors. But once you know that one particular user is closer to other, then the recommendations can be pushed. So it could be user based recommendation or item based recommendation. So two items which are similar in nature. So if one person likes item A and item B is similar to item A, maybe item B also can be pushed to that user. So it could be based on item collaboration or user collaboration. So and if you look at the new generation solutions, all these people are using recommendations now, but it was made popular by Amazon and Netflix to begin with. Okay. Now, the thing is, I have been telling a lot of good stories about analytics. Now, can it go wrong? Yes, it could go wrong. I'm going to quote a popular example that most of us are aware of. Paul, the octopus in Germany, which has predicted the winner for various matches in the 2010 FIFA World Cup. At that time, the octopus predicted the outcome for around 14 matches, and it actually predicted the winner on 11 occasions or so far. 11 occasions, I guess, 10 or 11 occasions. How could that happen? Okay. Now, if you look at the way the process was done, octopus is in an aquarium, and you would have two plastic containers at two ends. The countries which are competing, the flags are actually put on top of the plastic container, right? Similar type of food was there, the same amount of food, say mussels or oysters or whatnot. So the prediction, the way it works is, when the octopus moves in whichever box it touches is considered as the winner. Okay. Since since Paul belongs to Germany, it has made a lot more productions for games involving Germany. Okay. And these are the three flags that I have put. The first one is the flag of Germany, second one is the flag of Spain, third one is the flag of Serbia. Of the 11 games played by Germany, Paul the Octopus chose 9 out of the, sorry, in the 14 choices, I think 11 games were won by Germany, out of which 9 were predicted correctly by Paul. Right? In the game where Spain and Germany played together, it selected Spain. In the finals, when Spain and Netherlands played, it selected Spain. But when Serbia and Germany played together, it selected Serbia. The thing is, there are a lot more known experimentations done on octopuses, which have actually summarized a lot of facts. Things like they have good memory, their vision is very good, but they are colorblind, but they could actually identify bright colors, and they have affinity towards straight lines. Okay. So in fact, what has happened is, Paul is not like a crystal ball, or it could predict the future or anything. Paul just touched the flag that it likes. It actually didn't care about who is the winner. Whichever flag that he had that liking, that is what he is going to touch. That is a confounding error. So we conveniently miss, or we conveniently discard the third or remaining factors when we do analysis. So analysis can go wrong when we do this kind of thing. And if you look at that other picture, correlation of two variables do not necessarily imply causation. This one says the sales of razors go up, and also the people with bald heads or shaved heads also goes up. So which means, if you become bald, is it going to make the sales of the razors go up? Maybe not. So correlation of two variables doesn't necessarily imply causation. But in many analytic scenarios, people conveniently discard this and arrive at conclusions. I'm playing a small video which shows how things could go wrong with connected devices and all that.
Smoothie.
Calendar.
No meetings today. Remember, dentist at 9:30.
Playing jazz.
Playing jazz.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, dentist at 9:30.
Fire off.
Fire off.
Open door.
Door open.
And we're gonna do one more.
Oh yeah. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open. Open door.
Repeat that.
Open door.
I didn't understand that.
Hey! Open door!
Play on the floor.
Get over the door! Open the door!
Wrong voice command. Error.
Hey there. With a rock? Open door. Open door. Open door! Higher!
Higher volume.
Higher!
Higher.
Higher!
Ja, hva kan jeg hjelpe deg med?
Jeg har vel fått litt rusk i forgaseren, da. Jeg vil heller mer at jeg har fått litt sånn... Fått litt noen sånne troll i trompeten.
Sorry. Okay. So now, what could go wrong with data processing? There could be chances that an unscrupulous researcher or unscrupulous person could lead to incorrect inferences, could lead us to incorrect inferences with manipulated data. Or a well-intentioned person might forget certain factors when he does the analysis. So, but the crux is, if you can manipulate data, if you could torture the data, you could actually make the data to talk the way you want. So that is why it is all the more important we do the data processing diligently to arrive at meaningful inferences. Now, needless to say, whether it is big data or small data, all are very critical for the organization's success. And we cannot think of an organization building any value offering, a product or a service without the use of data. So if you handle data diligently, that is going to reap benefits for you. Information is the oil of the century, the 21st century, and analytics is going to be the combustion engine with which organizations can move faster. Thank you. I'm open for questions.
Thank you, sir. Thank you for your session.